Problem. Prove that the product of the perpendicular distances from any point on the hyperbola to its asymptotes is constant. Now this is a given question. Given the product of the perpendicular distances from any point on the hyperbola to its asymptotes is constant. Product of the perpendicular distances. First we have to find the perpendicular distances from any point on the hyperbola to its asymptotes, and then we take the product of the perpendicular distances. Now we want to show that that value is equals to constant. So first we take the equation of the hyperbola. Equation of hyperbola is x square by a square minus y square by b square is equals to 1. Next we take the equations of asymptotes to this equation. Equations of asymptotes are: first equation is x by a plus y by b is equals to 0, and the second equation is x by a minus y by b equals to 0. Next we take any point on the hyperbola. Let p is equals to x1 y1 be any point on the hyperbola. Since it is a point on the hyperbola, the point satisfies the equation, that is x1 square by a square minus y1 square by b square is equals to 1. Next we take the perpendicular distances from x1 y1 to the first equation and from x1 y1 to the second equation. P1 is equals to perpendicular distance from x1 y1 to the first equation. From x1 y1 to x by a plus y by b equals to 0. That is equals to under modulus x1 by a plus y1 by b by square root of 1 by a square plus 1 by b square. Square root of a square plus b square, x quotient whole square plus y quotient whole square. This is the value of P1. Next finding the value of P2. P2 is equals to perpendicular distance from x1 y1 to the second equation, and this is equals to under modulus x1 by a minus y1 by b plus square root of 1 by a square plus 1 by b square. Now what we want? Product of the perpendicular distances, that is P1 into P2. Now we are taking the product of these two values. So P1 into P2 is equals to first value P1 value x1 by a plus y1 by b by square root of 1 by a square plus 1 by b square into P2 value under modulus x1 by a minus y1 by b by square root of 1 by a square plus 1 by b square. Now this is in the form of a plus b into a minus b, that is a square minus b square. X1 by a whole square minus y1 by b whole square by root 1 by a square plus 1 by b square into root 1 by a square plus 1 by b square, that is 1 by a square plus 1 by b square. And this is equals to x1 square by a square minus y1 square by b square by taking LCM we get a square plus b square by a square b square. And what is the value of x1 square by a square minus y1 square by b square? This is nothing but 1. 1 by, since the point x1 y1 lies on the hyperbola, so x1 square by a square minus y1 square by b square equals to 1. So 1 by a square plus b square by a square, and this is equals to a square b square by a square plus b square, which is the constant. Therefore product of the perpendiculars from point on the hyperbola to its asymptotes is constant. That's all. Next problem, find the product of the lengths of the perpendiculars from any point on the hyperbola x square by 16 minus y square by 9 is equal to 1 to its asymptotes. So first here one hyperbola is given. So first we are writing the hyperbola. Given equation of hyperbola is x square by 16 minus y square by 9 is equals to 1. When we compare this equation with x square by a square minus y square by b square is equals to 1, then the value of a square is equals to 16 and the value of b square is equals to 9. Now what is the given question? Find the product of the lengths of the perpendiculars from a point on the hyperbola to its asymptotes. Already in the last sum we proved that the product of the lengths of the perpendiculars value is equals to a square b square by a square plus b square. That formula to find the answer here. Therefore product of the perpendicular distances is equals to the product of the perpendicular distances from any point on the hyperbola to its asymptotes is equals to a square b square by a square plus b square. Now replacing the values, 16 into 9 by 16 plus 9, and this is equals to 144 by 25. That's all. That's the answer. Problem: find the equation of the hyperbola of given length of transverse axis 6 whose vertex bisects the distance between the center and the focus. Find the equation of the hyperbola. We want to find the equation of the hyperbola. What is given? Given that length of the transverse axis is equals to 6, and also given that vertex bisects the distance between the center and the focus. So first we take the equation of the hyperbola, that is taken as, let equation of hyperbola be x square by a square minus y square by b square is equals to 1. X square by a square minus y square by b square is equals to 1. Next I take the graphical representation. Now this is the diagram of the hyperbola. Focus S, S dash, these are the vertices a comma a dash. These are the directrices, L is equals to 0, L dash is equals to 0. This is the center of the hyperbola. Now what is given? The vertex bisects the distance between center and focus. Suppose this is the vertex. We take this vertex. Vertex bisects the distance between the center and focus. That is, this is the midpoint of these 2 points. Since this is the midpoint, these two distances values are equal. So that is the given data. Given that CA is equals to AS. Now what is CA value? This total value is equals to 2A. A dash, this total value is equals to 2A, then half value is equals to small a. So this is CA value. And what is CS? CS is equals to distance between center to the focus, that is AE. So here from the diagram clearly we can take that CS is equals to AE and CA is equals to A. By equating these two values we can find the equation of the hyperbola, that is the procedure. So first we write the given data. Given that length of transverse axis is equals to 6. Length of transverse axis is equal to 6 means 2A is equals to 6, then the value of A is equals to 3. And also given that the vertex bisects the distance between center and focus, that is given that A is the midpoint of CS. A is midpoint of CS, that is CA is equals to AS. What is CA value? CA is equals to A, and what is AS value? Clearly from the diagram AS is equals to AE minus A. This is nothing but this total value minus A, that is AE minus A, which implies A plus A. 2A is equals to AE, then the value of 2 is equals to E, that is E is equals to 2. Already here we have that A is equals to 3. Now it is enough to find the value of B. Now how we find that value? By applying the formula B square is equals to A square into E square minus 1. That is A square 9 into E square minus 1, 4 minus 1. 9 into 3 equals to 27. Therefore, equation of hyperbola is x square by a square minus y square by b square is equals to 1. That is x square by a is equal to 3. A square 9 minus y square by b square. B square value 27 equals to 1. That's all.